Devil or let's see, Mark, are you up?
How you all doing today? All right.
I'll translate into Spanish if you need it.
See. Hey, my name's Mark Lee. I'm the founder of Better World Builders. This is my partner Dale Neville. We've been working together for the past 10 years on building a better world. Um, Dale has been part of retrofitting homes for all of his career for the past 30 years practically. But together we've kind of figured out ways that we can help um, take existing houses and make them better. And we fix houses. A lot of times we fix houses. We also get into some new construction. We'll talk about a few of these projects here. Um, so today, I think one of the questions was someone asked that question of what does it take to take an existing house and retrofit that to a zero net energy house. And that's what we're going to step through a little bit of that, and then we'll step through some of the projects that we've completed, and as well as what it takes to make that thermal. More than 50% of our energy in our house is usually consumed by heating and cooling it. So how do we take that and drop that load down so that it can be a zero ready house or a zero net ready house? Which button do I push? That one. Okay. Great. So, basic idea, and I think you hear about this a lot: validation, and certifying what you do. A lot of times, what we start off with doing is getting ready to, um, whenever we get into doing any type of work, we test the house first. We do a blower door test, we do infrared scans. It's amazing what you could find in those things, and and so that's our basic part of it. I'm going to just talk about, we talk about developing a zero net ready thermal envelope, some of the challenges and insights. In general, I think a lot of people, we've already kind of talked about this part, but that strategy of what it is when you're taking that whole house approach and making reducing the waste that's in a lot of our houses. Um, but here we go. So two ways. I think we've heard a lot about new construction and what you could do with a new construction house. Uh, some of the cost factors involved in that. It could be pretty high. $200 a square foot to $300 a square foot for our area. Maybe in Illinois and Chicago, $600. I mean, it's a whole different range there. But here in the West Michigan area, we're probably closer to that $200 to $300 a square foot. And when you're doing that, obviously you're gonna do all those things of that were just talked about through our value, and been talking about that initial design, following the right patterns to make that house correct. But just down here in the bottom here, that's if you're building an 1,800 square foot house, you're into it for about $500,000. So we're based in Kalamazoo. We love Kalamazoo. We love the houses in there. Um, I have a question. So raise your hand if you live in a house that was built before 2000. Yeah, it's almost everybody in this room. Uh, so taking care of what you have has such a great environmental impact. It has, not new materials are not harvested to make a new construction house. So living with what you have and trying to make that better, make that house love you, is a little bit. Well, it's a lot of what we're about. Um, so we look at Kalamazoo. Kalamazoo is great value for homes. A lot of houses sell in Kalamazoo on average between $75 and $108 a square foot. So you could buy a nice house, in Kalamazoo. Property's already there. Your utilities are already there. Your water, your gas lines are already set up for about 135 to maybe $150,000. So in looking at the basics of where do we start, um, there's I think someone talked about the TED energy monitor earlier, and that TED energy monitor earlier. They just referred to it. When you are conscious of how much energy you're using, and you see it, you can actually reduce it. Just voluntarily by 10%, turning off the lights, turning off that TV, shutting down your computer at the end of the night. So just some of the basic things of that is a very easy first step. Um, Closing and locking the windows during the winter time. These are real basic steps, as well as ventilating smart, using your bathroom ventilation fans, as well as cleaning the dryer vents. Basic maintenance items. Once again, these are basic items that if you clean the lint out of your dryer vent, your clothes will dry faster. It's an interesting thing. So you just kind of you all of a sudden you're saving some energy, clean and tune your furnace, as well as Wi-Fi thermostat. So this is all kind of low hanging fruit, and by doing some of these things, we can gain that 8 to 10%. And okay, yeah, just talking about some of the once again the houses cost in our area. So uh, what we typically do when we're talking with homeowners is we'll help them with a baseline assessment. In that time of doing a baseline assessment, we're looking for those leaky areas, those drafty rooms, poor insulation, and then we look at old windows and doors, as well as low efficiency, energy efficiency appliances, and old furnace and air conditioners. I'm going to go back to that first one, that part about we've talked about leaky houses. I think that's mentioned. That theme is very apparent. Seal it right, ventilate it right. Next step is that insulation aspect. Since most of us are living in a house that's built before 2000, I think in our area, 85% of our houses are built before 2000, and a lot of those houses have fiberglass insulation or old insulation, vermiculite insulation. Fiberglass insulation is one of those ones where if a rodent crawls through it, they do their business. They don't mind crawling through it. They crawl through your walls. They start to crush the fiberglass inside the walls. You could see this with an infrared camera when you're doing an energy audit. And every time that happens, there's a lot of dirt left behind. You know, if a rodent's in your attic, it's leaving some of its business in that attic. And if it's crawled through your walls, it's leaving its business in there too. So one of the key things that I think with Dale and I we've found very successful is we pull out all the insulation in the house. We'll take a big vacuum. We have a street cleaning leaf vacuum that Dale found, and he's converted it to so we could roll up to a house and unload this vacuum, this big hose off of this big truck mounted vacuum, and suck out all the insulation out of the attic. We'll take that same truck and then we'll open up the wall cavities, and usually there's fiberglass in those wall cavities. We'll reach our hands up in there and we'll yank that stuff out. Same with if there's been old blown in cellulose or rock wool or any of those materials, we have some methods where we jab it with air and then suck it out with the vacuum. Key thing part of that is that when we're taking out that old insulation, it is like it's adding health benefits to the homeowners, because if you can imagine insulation that's been rodents have been crawling in it for the past 50 years or 80 years, it's kind of like wearing dirty clothes. And before you put on new clothes, you want to take off all your old clothes, wash them, take a shower, and then reapply. That's kind of what we do with houses. So huge strides can be made right there, from that health and safety aspect, and then correcting those items in here. Um, this is just I'm going to buzz through this rather quickly, but this part is just talking about the energy loss points, the common places where you'd find it: having poor insulation, air leaks, and an unzipped house. It's like having wearing an unzipped coat in the wintertime, and then correcting the thermal boundaries. So just looking at that outline of what happens when you correct the thermal boundaries throughout the roof, throughout the collar system, throughout the wall system, and the foundation. By doing this, just with an average house, uh, we will put in R50 up in an attic, correct the walls and make those R13, R19, add insulation down in the basement, and a lot of the question is like, how much does this cost? This is the value equation. Um, the retrofitting costs on average about $6 to $15 per square foot. But by doing this first step, you're making your house a lot more energy efficient, and you're taking anywhere from 20 to 50% of your heating and cooling load is cured just with this first step. But if the goal is to get to zero net energy, what next steps do you really need to take? So after we kind of have that idea, I see Brad Bartholomew here. We work with Bartholomew Heating and Cooling quite a bit. After the whole envelope is taken care of, then we start to look at the heating and cooling system. Sometimes we're looking at furnaces. Sometimes we're looking at geothermal systems or air source heat pumps, ductless mini splits, um, and then as well as the water heating and the air quality, the ventilating right. So once again, this is that idea of what's that retrofit piece going to cost. That adds another $6 to $18 when you start to replace out old systems and put in new electrified systems. Um, window upgrades, another kind of a costly piece, but it can be that big component when you're modeling every house. Every house may have a good opportunity in changing out the windows. Frequently, it doesn't. From that initial cost standpoint, but by doing that, we can eliminate another 6% in that waste area. I think I'm not sure if you could see that up there, but that's where in the yellow circle it kind of talks about what percentages are coming off of there. Um, these are deeper energy retrofit things. When we start getting into, we call them the doors and the windows, changing those things out. With windows, like I think it's been mentioned, where most windows, those double pane windows, they're going to give us an R value about 3.5%. When we start to get into these high tech windows where they're trying to get to R8 or higher, they become enormously costly. One of the methods that we've been using and had some nice success with is actually using cellular window shades. The cellular window shades will actually, when used properly, they can block that sun. They can also perform like a thermal blanket in the wintertime. So by using the thermal shades, those can be had for a lot less expensive than actually replacing all of your window systems. Moving on to that deep energy retrofit. This is that step where we take, and I think we're talking about it we're using T-studs, and the house that Eric Hughes mentioned earlier regarding the Pines. This is a house out in Gobles that we're really excited about having this opportunity to retrofit this house, an 1890s farmhouse that had some good intention behind it initially. One of the big things that's already taken care of is that the foundation is already an ICF. It's an ICF system. Yeah, there we go. But they put that down there already, and so now our next steps is to address that shell. And do you want to talk about the shell and what we're going to be doing there?
Yep. And one thing that Eric Hughes mentioned that I want to point out again is they left us a nice 4 to 5 inch ledge around the house. So it kind of narrowed our choices down as to what we're going to do to correct that problem. We can't end up with a ledge, like this around the house because that's the way it's set right now. So we're kind of using the T-stud to take up some of that space on the outside because we're going to add a 6-inch stud to the exterior. One of the things also that the T-stud has allowed us to do that's different than some of the deep energy retrofits that we've done in the past. In the past, we've done hybrid wall systems, if you're familiar with that. Anybody familiar with hybrid wall systems? Yes. Hybrid wall system, in short, is where we don't align the new studs on the exterior purposely so that we don't allow for the thermal bridging. The nice thing about the T-stud is that we can absolutely align it with the old studs and we don't have the thermal bridging. So it's much easier now to reframe a house from the exterior using the T-studs concept. So that kind of narrowed it down. Another challenge on this house in a lot of houses, I haven't heard a lot of mention about this, but the perimeter of a house where the rafter tails die down, we do still have some thermal bridging that is going to happen there because you're not going to get an R80 or R90 what's proposed on a lot of these projects. So we tend to look at maybe adding some foam also to even that out. We do want a contiguous R value. It was mentioned by the prior gentleman here that having equalized R values is just as important as having high R values. So when Eric and I were modeling the facility, we're just kind of bouncing back and forth numbers on what are we going to end up with a finished RVAD. What are we going to end up with as far as the leakage characteristics of this house too, because all of those have factors that play into this. And like I was saying, we're going to want to raise the whole roof system. So to do that effectively, we'll probably most likely be adding on to the height of the existing framing, because that's a little more cost effective than just stripping the whole roof system off, which we've done many times to put a raised heel truss on. We're going to simulate that same effect by raising the whole roof system up, which I did in my personal home. And then you add that height to the exterior wall system. So to kind of make it look like it grew that way, so to speak. Also noteworthy is that on a deep energy retrofit such as this, we're going to be using the Anderson A-Series the tri-pane windows. Well, we're going to gut every single window in the facility. And by doing so, it'll allow us to um, add the framing, much like what Brian explained with the T-stud. Um, we're going to put window bucks in to eliminate the thermal bridging around where the windows actually connect in. So every aspect of this house is going to be looked at and modeled, and we're gonna go back and forth with it with our designer before we ever pound a nail. Um, of course, then we have the challenge of maintaining the historical look of the home, which is another huge challenge in this. Um, the lady's an orthodontist. The guy is a psychologist. Um, he's more for the historic value. She's pushing more for the net zero. So they've met somewhere in between, but he's assured me he's going to compromise when it comes right down to it, that we're going to focus more on net zero than the historic value of the house. This is going to be one of the most challenging projects that we've done because of the huge cubic dimensions of the house. The first gentleman with the geothermal and the second, Ted, the designer, was talking about, we want to keep the house to smaller cubic dimensions, and that helps with the net zero process. And that's absolutely correct. So there is another huge challenge, the fact that we have such a huge cubic dimension of air. We have tall ceilings in the space, and we just have a lot of rooms. So therefore, this is one where R value is going to play a huge a part of this. Is when you start adding cubic dimensions to a space, your R values do have to go up directly proportional to that. So there are some of the challenges.
Thanks, Joe. Yeah, so just kind of building on that, hopefully next year we'll have a whole case study on how this house went and how successful it went. All right, so yeah, if we're still alive, and it should be done by then, but we'll see. We have had some other pieces where challenges do come into play. Anyway, kind of building off of the next steps of after you go through these 6 steps of reducing and figuring out how to take what you have and correct it, and then replacing your mechanicals, then getting into the deep energy retrofits, then you're adding solar panels after that. So these are kind of the sequence, the logic in how we could build this and make that happen. That's our little pictures of the sun and solar panels hitting it. So just kind of a quick one on here, looking at what the cost difference between building a new house and taking what you have and making it a retrofit. This breaks it down a little bit, but most people already have their first mortgage on their house and they're still working on it. To go from here to make it a net zero, you're almost buying another house. You might be adding $100,000 to this house, or more. But by the end of the day, you can actually preserve what you have and make it work better with retrofitting it. I have 1 minute left, so this is I'm going to go through this real quick. This is a project that we did. Eric Hughes was designer on this one, old farmhouse in Lawrence, Michigan. We put in a shale frost protected floor using InsoFast, not InsoFast, but monoslab easy form on the foundation for that. And then we ran into a whole bunch of crazy things on the inside of this house. We ran into the asbestos. We ran into bats that had these mites that, once we tapped into that, it just started biting everybody on the job site. Real crazy thing. Cellulose dense packed inside, foam on the outside. We took care of the attic. Everything's air sealed up there. R60 up there. Beautiful house when it's all said and done. So that's one of those pieces right there. And I think I probably should wrap it up right at this point. I'll leave it at that. So thanks very much.
Thanks, Mark. And I think we've got a few questions. So questions for Brian, Jake, Mark, Dale.